I'll let the others in as they join. So good morning, everyone. Thank you for joining us today. And today at the latest ECSA EU Citizen Science webinar, we have Jackie Goldin, who's an anthropologist from the University of the Western Cape in Cape Town. And she's going to be talking to us about a citizen science monitoring project that monitors groundwater in Hout catchment in Limpopo. So I'll hand over to you, Jackie.
Thank you, Tim, and hello to everybody. I can't see all your faces, but that's obviously the downside of not being in a room together, but thank you for being there. So I'm going to present and then we're going to have questions afterwards. And if I'm going too fast, do press your unmute and let me know so that it's clear to all of you. Okay, so the project has been, the acronym is CISMOL. It's a citizen science monitoring groundwater in the Hout catchment in the Limpopo. Sorry, Tim, when I press my button to go down, it's not going down. Is there a reason? Ah, okay. So at the moment, it's a Water Research Commission funded project, which is piggybacking on top of the ECSA project funded by Danida, Enhanced Sustainable Use of Groundwater, which was to develop and assess a CS approach that contributes observations to support an understanding of catchment hydrology, and importantly, to equip local stakeholders to better participate in water resources management. Yeah, I'm not sure why it doesn't go the first time I press the button. Have you got any? Yeah, I'm not quite okay. So we're addressing a hydrological void, and the fact that in these remote rural areas, in a place like Limpopo, which is very isolated and there are huge distances between one village and another, it's very difficult for the Department of Water Affairs to monitor and have access to data. So we're addressing this hydrological void that is in the municipal and governmental databases. So the Hout catchment is an area of about 2,400 square meters, and there's one big dam in it. But as is the case with most of the rural areas in South Africa, there's 74% of the rural population who are completely dependent on groundwater. So this is on local wells and pumps. So the uptake of citizen science is augmenting also this dwindling budget for groundwater monitoring that Department of Water faces. As I say, the kind of difficulty of reaching these wells in very remote settings. So mismanagement by vandalism and mismanagement of these wells leads to adverse impact effects on the ecosystem. So it's really important that one engages with stakeholders and gets a better management and better understanding of the groundwater. And within the context of groundwater monitoring in the Hout catchment, there's this new relationship which has been established between technical experts, between government and society. So today's seminar, I'm presenting some key ideas. The first is the idea of the living labs, and these are all linked with citizen science. Then briefly, I'm going to look at the Sustainable Development Goals, and then the citizen science theoretical aspect. And I'm sorry for those of you who are very involved in citizen science who might already have that theoretical aspect, but for others perhaps not. And then citizen science, its practical application. I'm going to then look at monitoring and evaluation aspects of citizen science. And with that comes research integrity. And then we will have concluding remarks. So the European Network of Living Labs was established, and it was in 2006, there was funding given to living labs, but the idea goes back to the 80s, but it kind of really precipitated the idea of a living lab once the European Commission started putting funding into these projects. So living labs foster innovation in an iterative process of gradually improving and gradually refining a product in successive stages, What's interesting with the living lab is that the end is not fixed in the beginning. You don't really know where you're going always. And the design becomes more concrete as you go along. And that it's the idea of co-creating products and services. So living labs can be any space, anywhere, suitable for collaborative design and the application of knowledge. And the importance is that it's about empowerment, upliftment, and development of people on the ground. And the idea is then to get better innovation and better management of projects. What makes living labs really interesting is that this traditional role of who is the researcher and who is not the researcher, who's the academic, who's the expert, who isn't the expert, what do we expect from people, is much more blurred. So there are various kinds of knowledges which are considered equal while still not the same. So there are different people generating different kind of knowledges. There's also the creation of trust, and the creation of trust involves an emancipatory process. So living labs have a very important role to play in improving trust. And I'm going to show a little later in the presentation how, in fact, trust can be brokered. So looking at the Sustainable Development Goals, we know we've got goal 3, which is good health and well-being, goal 5, which is gender equality, goal 6, which is clean water and sanitation, goal 10, which is reduced inequality, 16, peace and justice, and 17, partnerships. And these are all part of citizen science addresses all of these, but in particular, we're looking at goal 10, which is about reducing inequality. And as one acquires knowledge and with it the power to make decisions and better understand the environment, these inequalities, but often due to knowledge inequalities, are reduced. So this is a rather lovely quote, which I'd like to read to you from Russell. And this is about citizen science. This is Renaissance. Your dentist, now an authority on butterflies. Pygmy hunters and gatherers use smartphones to document deforestation in the Congo Basin. High school students identify fossils in soils from ancient seas. Do-it-yourself biologists make centrifuges at home. This is falling in love with the world, and this is science. And at the risk of sounding too much an idealist, I have come to believe they are the same thing. So the field celebrated a milestone when citizen science only in 2014 appeared in the Oxford English Dictionary with one of the many definitions for citizen science is the collection and the analysis of data relating to the natural world by members of the general public as part of a collaborative project with professional scientists. So we see with citizen science projects, we have this skew. Most of the projects, and I'm going to show you just a couple of them now, at least 80% of the projects belong to the natural sciences. And I think Tim will confirm this with his experience in the European Citizen Science Association. Only about 10% of projects are in the social sciences and humanities. So the next two slides show two projects that are part of the natural sciences. And interestingly, this goes right back to the year 1200, when in Japan, many people around Japan were looking at blossoms and were capturing data that was so accurate, it was able to be used for climate reconstruction. In 1736, Robert Marsham, on his family estate in Norfolk, was capturing 27 phenological events, such as first flowering, leafing, appearance of migratory birds. And these, again, were very competent and scientific observations that were done by ordinary people, the citizens. There seem to be about 1,500 projects globally. I stand to be corrected. And of these, about 200 are active projects in Africa. So we're demonstrating a proof of concept, which that CS is not just relevant, but it empowers citizens. By empowering citizens, it has intrinsic value. In other words, to be empowered has an intrinsic value, but it also has an extrinsic value, which by being empowered, you can improve groundwater management. Here's the Hout catchment. There's Innocent with his mask. Innocent is attending today's webinar, and he will answer any of the more technical questions because he's the groundwater expert in the technical, and he's on the ground very regularly with the scientists. So Innocent is the person to go to with many of the questions if you have. We've divided the Hout into three sections. And these sections are according to the inhabitants, whether they are small-scale farmers or, as you see on the right, in section 2, commercial farmers. There's a huge difference. The small-scale farmers usually have 10 hectares or less of land, whereas the commercial farmers in the middle of the catchment often have up to 100 hectares at least, if not more, and many wells, and they're much more experienced in collecting data. So dividing the catchment in this way was quite useful for us. Sorry, I just seem to sometimes the slide blocks and doesn't go forward. So what's interesting is when you look at the catchment division, is that data obtained in one well is shared with data that is obtained in other wells. So people get a sense of belonging to a larger catchment and being embedded in these catchments and embedded with people who also depend on the resource for their well-being. This slide shows another aspect of the citizen science project, which was a very technical aspect where there were boreholes being drilled to measure, pumping boreholes to measure groundwater. And what was fascinating for me as the social scientist in a huge team of interdisciplinary scientists, and I think many of you have probably worked in big interdisciplinary teams, is that there's this kind of what I call this jangling discord, where the social scientists and the technical scientists are just not talking to each other at all. And there are things going on, these two photographs on the right-hand side, in proximity to each other, and people don't know what the other is doing. So there's this kind of moments when you are fleeting moments when you are connecting with one another, and many moments when you are not, and different parts of the team are really going off on different and in different angles. Citizen science relies on particular techniques to get people engaged. So I'm going to show now a few slides with some exercises around participatory action research. I'm not going to go into this typology of participation, but just to say that there are different levels of participation. The one is really just telling people what to do, or getting people to participate, but you're in control and it's kind of top down. And the bottom is self-mobilization, where people are getting involved, and they're very much involved, and they're helping give direction to the project. And they really are, that's what we're aiming at in our citizen science project, that there's real engagement. So Rachel Slocum provides an overview of participatory approaches and multimedia tools. And I'm going to show you a couple of these tools that we have used to raise consciousness, to gather data, and for community decision-making and action. So just to say, the shared mindset between the Living Labs, participatory and practice is that there's openness, continuity, and empowerment of users. And there's kind of spontaneity and realism. So you listen to the voices of people and what they're needing at particular times, and that might change the direction of where your project is going. One of the powerful exercises that we like using is the river of life. So you give about 20 minutes to each of the participants in a stakeholder workshop, and you ask them questions. You ask them to draw a river. If your life were a river, what shape would it be taking? Where would it be bending? Where are there transitions? What are the obstacles or life-altering moments? What's brought you here to this particular place in the context of this workshop? And where has your river been flowing very powerfully? Where is it only kind of trickling by? So if you were to divide your life, where would the divisions occur? What are the tributaries? What are the tribulations? And then not only what are your own joys and your own pains, your own hope, your own feelings of dignity, of pride, or the contrary, of shame, perhaps, but what also is happening in the world around you. It might be the elections, it might be like, Mandela released from prison, whatever. There might be big round the world, around your world, incidences that are shaping your river. And this is just taken from a poem by Machado, which is Path Maker. There is no path. You make the path by walking. By walking, you make the path. And this is really pertinent to citizen science, where we're saying we don't have the answers when we start the project. We're developing our responses and our answers in collaboration with our citizen scientists. This is just a rendering of a river of life drawing showing smileys, things that were life-changing. People got work or didn't get work. Maybe somebody died in your family. Maybe somebody came into the village and gave you new directions. So it's a powerful, and it's a really, it's a great icebreaker, but it's also a very useful reflective tool. The second tool we use is actor networking mapping, where we try and find out who each stakeholder is involved with, how important they are. On the axis at the bottom, is it whether they are minor importance or moderate or major importance? And then who is missing? Who should be here in your area, or who should be part of this project, who is not? So who's visible and who is not visible? A very useful exercise we spend quite a lot of time on, and we do over and over again, is participatory mapping. So this is when you're asking your citizen scientists to help identify boreholes on the map. But really what you're doing here is you're gathering real-time, real data, and it's from people who are residing in the catchment. In this case, people were showing and putting on stickies and showing where there are boreholes and where there are wells in the catchment. And this is a much more complicated map, but we were asking here to put in the rivers, where the rivers are dry, which rivers are flowing, to show contamination points, where there are wastewater treatment plants, and so to put in the hydrological and contamination features onto this map. So what's really important for us is that these maps were extremely accurate when compared to maps that so-called scientists or experts were producing of the area. The citizen scientists themselves were giving us information. There's not enough information in this rural area. So the citizens who live close to the wells were becoming scientists themselves and transmitting really valuable data on groundwater. So this participatory mapping and the River of Life exercise, or the actor network mapping, co-creates this enabling workshop where you get information, and the choices last after the actual workshop. You're sharing power, building relationships, establishing communication, and importantly, what comes up again and again, and you'll see in this presentation, you're negotiating change and transformation. The next two slides, this and the other slide, is graphic facilitation. We found it was helpful, instead of having a normal kind of dry report to tell people what was happening at the workshop, we used a graphic designer and we created these storyboards, which show, ideas of partnerships of mutual benefit, show the ideas behind the living lab. And there you can see in the middle, diamonds on the soles of our feet, which is a journal article we in the process of writing. And diamonds on the soles of our feet, I think captures very well the idea that those who are on the ground have rich data. They have got really diamonds on the soles of their feet as they share the knowledge that they have with others. And this was the second storyboard, which is about authentic learning. And that's an idea that comes from Bozilak, but also Suransky, on authentic learning and looking at difference and diversity. Not one case fits all. You're looking at differences in geological differences, differences in education, and the fluidity. So we kind of use this metaphor often of the river. What, where are the easy times? Did you feel angry? Have you felt disappointed? So there are a lot of these kind of emotions, and we draw emotions and thoughts into the work we're doing with citizen scientists. Once again, it's just not going. I'm not quite sure why I can't get. I'm going to look now at the monitoring and evaluation. And so, first of all, we used participatory methods to develop indicators. We asked questions: what do we need to know about behavior? What do people do? How much do people do? How often do they do it? When do they do it? Where do they do it? Who do they do it with? Why do they do it? And what is required to do things differently? So as we respond to these questions, we keep in mind three ideas of people, power, and practice. So there's the concept of a collaborative process of research with elements of education and action that are explicitly directed towards what I've mentioned already: change and social transformation. So these are images on the ground, which is people capturing rainfall readings from rainfall gauges. And this information then gets put onto smartphones and gets sent to a website, which is available and accessible by the citizen scientists and also by the Department of Water Affairs, Department of Agriculture, Agricultural Union. So it's an accessible, user-friendly database. And there's just like a diary of one of the citizen scientists writing about the rainfall that he or she had captured during the day. These are just some of the instruments: the dip meter, the rain gauge, the measurements that are part of the materiality. We talk about the material, which is the kind of tangible aspect of citizen science, and then the immaterial, which is the intangible, or sorry, immaterial is not the correct word, but the intangible or the emotional aspects. This is a graph of the groundwater level that's put onto the citizen science app. So we've established a monitoring and evaluation frame, which asks the following questions, is based on the following: which indicators are highly relevant and determine the success or failure of the project? Which indicators are highly relevant but are not a deal breaker for the success of the project? Which indicators are not critical for the success of the projects, and which indicators are very important but are not showing maximum performance? So we look at our indicators and we decide which ones we really need to look at. And this frame is generic, so it can be used also for similar surface or subsurface characteristics of water, but also beyond. And we're hoping it's going to be used beyond South Africa, not just in South Africa, and also not only with the natural sciences, but across that spectrum of social science, humanities, natural sciences. This is just the slide and the next slide show some of the indicators, and because it was interactive, once again, we use smileys. For instance, do you have competence to train other volunteers? Yes, but I require more training. Are you happy with the process? Yes. A couple said no, but most said yes. So we've done this list of indicators for all our volunteers. Would you be able to train others? Is your borehole your own, or is it in a public space? Are you regularly taking photographs of the rivers? And an important question was, do you have competence to train other volunteers? Because ECSA has identified what we call champions, and I'll show you a photograph of one of the champions just now, which are people who, citizen scientists who've said, yes, they feel very competent in what they're doing, so competent that they're really willing and would like to train other citizen scientists. So part of the monitoring and evaluation, that if you do not measure results, you cannot tell successes from failure. If you cannot see success, you cannot reward it. If you cannot reward success, you might be rewarding failure. If you cannot see your success, you cannot learn from it. If you cannot recognize failure, you cannot correct it. And if you can demonstrate results, you win public support. So for these reasons, monitoring and evaluation is really important. So this is one of the champions that ECSA has identified. And there you see him with a larger dip meter than others, because he is going to be measuring not just in one borehole, but in many boreholes. So he needed a more robust instrument, and ECSA has just delivered this to him. And to stress again here, we talk over and over again in our work about these tangible concerns, the materiality, for instance, of this something like this dip meter, but also the intangible, the emotional aspects of feelings of pride or belonging or anxiety, perhaps, or whatever these intangible emotional aspects might be. So lines are drawn between the technical and the less technical. We draw lines between government and between different scales and institutional intersections. And part of the research integrity is that we're aware of risky emotions. For instance, when we did the River of Life, a couple of people were quite moved by having to think about some of the importance of tribulations that changed the tributaries of their river. And so we needed closure on some of those exercises. So they're risky emotions at times. One has to be careful not to offend and to take caution. And of course, the ethics of doing no harm. So these are just some of a word cloud, just capturing some of these ideas of research integrity, which are communication, which is to be aware of the emancipatory aspect of research, to develop trust, to be aware of how you broker trust and how you might break trust, and to have honesty in all aspects of the research. So you explain to the stakeholders what they can expect and what you can offer and what you can't offer. To have accountability, so to be honest from their side and from our side about what the weaknesses are in the research, where we possibly don't always know where we're going, and to encourage accountability by the citizen scientists as well. Then, of course, to be always professional, to consider conflicting views, to look at the integrity of the data, to have quality assurance of the data, and to be fair when working with others. So that's part of the professional courtesy. And then good stewardship of the research. So that's stewardship of, first of all, looking after the instruments, looking after the phones that you have, looking after the dip meters. If something breaks, to report on it as quickly as possible, but also having stewardship by sharing the data that's on the on the website, and having kind of a sense of ownership that this data belongs to you. So I'm now going into my concluding remarks. So citizen science involves a learning by doing. It involves participation, ownership, and processes associated. The idea is to do things in a way that you are increasing performances. So you're managing motivation. There's a moral aspect to it. You're improving accountability and responsibility. So this is just, I put the slide in because it shows that ideas behind citizen science, what which wasn't called citizen science then, are many decades ago. The work of Shoemaker that some of you might know, Small is Beautiful, which is a homage to the local, or the work of E.C.Sci.Sci, which is the discovery of the third world. And these works are looking at the promotion of eco-development. The premises in both of these is that ordinary people, because they are by no means ordinary, are capable of critical reflection and analysis, and that there's empowerment and transformation, and this involves real social change and requires research methods, which I've spoken a little bit about already, which are conducive to this transformation and change. You're not going to get this change or this emancipation without methods that allow for a process that encourages change and transformation. And I've mentioned trust, and I'm going to here again talk about trust as a good emotional feeling. And trust has intrinsic and extrinsic value. It's central to human relationships, of course, including romantic relationships, family, businesses, business operations, politics, medical practice. If you don't trust your doctor or your psychotherapist, you're not going to benefit from their professional advice. And if people don't trust the researchers, they're not going to benefit from any of the advice that the researchers might give the citizen scientists. And if we don't trust the citizen scientists, we're not going to benefit from the data or from what the citizen scientists are trying to tell ourselves. So mistrusting someone is not just a prediction of betrayal, but it's a bad emotional feeling about the untrustworthy person. But we want to stay on trust as a good emotional feeling and nurture and broker trust. Trust is interesting. It's something we carry in our hearts and our heads. It doesn't wear out with use, but rather it wears out with disuse. It's not easy to observe and measure. As such, it isn't intangible, and it's hard to construct. You can't force trust through external interventions. You've got to engage in processes to develop trust. So the rules of the game, I don't use the word game at all lightly. I take it as something very seriously, where you're behaving within a given social context and you embed it in concrete. They're often fluid, ongoing systems of social relations between tribal authorities, tribal chiefs, your councillors, your political leaders, agricultural union, Department of Water Affairs, Department of Agriculture, etc., etc. So the rules that each of these institutional bodies have, and we were really careful, for instance, in making sure when we went into areas where the tribal authority is in charge, that the tribal authority was properly approached, and at the time, a sufficient time was given and letter that was appropriate to the tribal authority to explain the project and to explain the role of the citizen scientists. So we see citizen science as a long journey. It's not an end. Differences and highly differentiated needs are acknowledged in their specificity. We ensure that no one is left behind in attaining water literacy and attaining trust, and attaining the intangibles and the emancipatory processes that we've spoken about. We draw here on feminist philosophers such as Nancy Fraser, Iris Young, Karolina Suransky, Vivian Bozilek, and others who consider diversity and difference. That is, each person is special and is different. You're not looking at a group of homogeneous citizen scientists. You're not looking at this universality, but rather you're considering difference in age, difference in feelings, difference in gender, all the diversity and difference that is so important when working on the ground in citizen science. We developed a citizen science framework, which was based on what I've spoken now today about trust, the idea of the living lab, the sustainable development goals, and then arriving at citizen science. So through this frame, the humanities is meeting the natural sciences. So this continuum and this kind of gap, what I spoke about is sort of a jangling discord between the technical and the technical, is hopefully reduced. Engaging always with research integrity and the honesty, accountability, professionalism and stewardship that I spoke about there. And then citizen scientists acknowledging that they become real scientists. As we showed from those participatory maps and from the data, it's accurate. And Chris Lintott, who started the Citizen Alliance in Oxford, says how we can't, how we can rely on this data, and that it is accurate, and we must see it as real science. So this is just a word cloud which talks about this diversity and pluralism. It talks about agonistic learning, which is a phrase that Saransky coins, that you're learning, there's this fragility, there's this messiness, this disorderly disconnect, where you are cautionary, the things are often fraught. And I think this is really important to remember these words when one's looking at citizen science, and to be aware, and also of the time frames when you're engaging in these kind of disorderly or puzzling and often surprising. The end is often a surprise. Just another surprise, and taking on the analogy of water, water and meanderings of underground groundwater rivers, there was this loud and rather devious meandering, which we all know about, which was COVID-19, and it affected us very much. It meant that there needed to be agility on the part of the project team and the citizen science themselves in terms of how are we going to communicate, how are we going to verify the data, and how are we going to continue with our participatory processes. And this probably go down in history, measuring groundwater with a mask on, but in many ways, the citizens were more connected, not less connected. Innocent has been really fantastic in almost on a daily basis, engaging with the citizen science app, talking to the citizens. So in many ways, because we weren't having stakeholder workshops, which were one-offs, during the year, we are having this ongoing this dialogue with the citizens, and they're also talking to each other on the smartphone on the citizen science app. So in some ways there are less feelings of isolation and separation, although of course the human touch and being together and being able to be together in a workshop situation is always unique and very precious. And this is my last slide, and I find it appropriate to end with an image of Mandela when we're talking about citizen science, because we're talking about this emancipatory potential of citizen science, the citizens' contribution to research, to informing policymakers, to new science-based evidence, and this distinction between the professional within technical know-how and the citizen scientist, which now becomes so much more blurred. Who is the scientist? Who is the professional? So citizens become really technically savvy, and we're broadening this realm of citizen science and nurturing an emancipatory role. Thank you very much. And we open now to questions. Thank you.
Thank you very, very much, Jackie. That was a great presentation. Very, very interesting. And yes, we do have some questions came in right at the end. So thank you for those. I'll go through them one by one. So the first question is from Carolina Saransky, and it is, what were some of the challenges you met while building trust?
Thank you, Carolina. That's a really important an important question. I think in some ways we were very fortunate, because in some ways we kind of almost landed on the ground running. We had our first stakeholder workshop, and we thought, people might be suspicious or bored, or why are you bringing us here? But we found that perhaps through the exercises like the River of Life, which we did in our first stakeholder workshop, people were really enthusiastic. I mean, we had enough funds in the beginning for only 10 dip meters and 10 volunteers. And we found that out of the 30 people who came to the workshop, almost everybody wanted to be a citizen scientist and wanted to volunteer. I think trust broke possibly at some points when people started working on the ground, and they had problems with the material aspects of citizen science. For instance, it wasn't so easy to use the dip meter, and maybe they were a little bit more distrustful. What are we asking them to do? But then by addressing that and going very quickly to the field, in that time we didn't have COVID, and really listening, to where the problems were, I think we managed to narrow those gaps. So without being, trying to be too optimistic, or I can say that we really didn't experience that much. We experienced trust. Where there was more distrust, Carolina, was with the commercial farmers. They are a much more organized group. They belong to the agricultural union, and their questions were much more, why do you want, we've been gathering data for years, why do you want to come to our farms? What are you going to do on our farms? Why must we talk to small scale farmers? So at the beginning, it took almost a year for us to build trust with the commercial farmers. That was a long and slow process, and it's ongoing, and looks like we've got trust now, and we've got buy-in, and they've actually asked us to train some of their farm laborers on their behalf. So that's like a huge move for us, but that took a long time, and it was really difficult to build that trust. I hope I've answered your question.
And so the next question is from Ian, and it is, can you explain more on the monitoring equipment use, please? High or low tech, easy or hard learning curve, costs, etc. That may be a question for Innocent, I guess.
Yes, Innocent, could you speak a little bit about the cost and about whether this is high tech or low tech? It'd be really great if you can answer that. Thank you. You'll have to unmute yourself, Innocent.
Okay, yes, I've unmuted myself. I'm not sure if you can also see me, see my video.
Yeah, we can, Innocent, thank you.
Okay, yes. In terms of the equipment that was used, I would say it was just a mix, but most of it was standard. The one that needed a minimum level of literacy, like the groundwater, the one, the rain gauge, everyone, at one point we learned about the rain gauge, but using it, some of the people had not used it, but it's still a very useful data collection tool that can be used by anyone. So that one's they had to make them undergo this retraining on the basic, some of the basic, but of course we have also some like the depth to, the one that was used to measure the depth to water level, the groundwater level. It was slightly technical. We took our time to try to train them, and because of the enthusiasm that they had, they were very much able to measure depth to water level. Of course, the principle is actually more of the tape measuring from using tape measure, but we're also planning to also introduce them to the digital ones, the one that automatically measure water level. That one, we can only do that with in collaboration with the Department of Water and Sanitation, because the data downloading from those centers is slightly different. It needs certain complications, certain procedures and processes. But there are some who are already interested. Can I also mention on another platform that even some of our champions, the champions that we selected or were identified, would even go on even to identify several other borers to tell us, okay, we can, while this we're monitoring our water level on this we can also proceed to go and monitor these other things that are water related, even at other different places. And yes, like the river gauges, they are simple to use, but they are because of the enthusiasm that this guy said, they could even know where to place them, the placement of those river gauges in people in the sites where the flow was. They would do that and take photos and send us the readings. At times we could also assist by extracting the exact values that we needed from them. And then they would just send us a full photo of what we need to extract from them. Thank you.
Thank you very much, Innocent. We have a second part of the question from Ian, and that is, how was the data presented back to the participants? I imagine how this was done could help or hinder the feeling of community and stewardship of a shared resource.
Innocent, add anything if you can, but basically the citizen science app is available to the citizens, and Innocent has taught the citizens, they've asked themselves, they wanted to learn how to read the data. So that those graphs that I showed you aren't always easy to read. So they have access to the data through the citizen science app. And we've encouraged through the citizen science app, sorry, that's on the web, a web-based citizen science app. There is a phone app where we've encouraged speaking to each other so that we get an upstream, downstream communication. That's not yet working well enough. We find people in the section 1 talk to each other, people in section 3 talk to each other, but section 1, 3 aren't talking to each other. We haven't yet started with section 2 with the training. Well, the couple of farm laborers have been trained, but that's going to be expanded within the next month or two. So it's through that talking to each other that the data is shared and that there's a sense of stewardship. This is our data, this belongs to us, we've gathered it, it's reliable, and this is what it's telling us. I hope that answers your question.
Yes, and in addition, we also we also do some visits when we could do visit them. We also carry along our data and explain them the implications and the meaning, especially the volunteers, the citizen scientists, and the ones who have got the 10-hectare plots. They also need this data for the planning of their agricultural activities and the knowledge of how when to plant, how much then can they plant and everything. So we also have this engagement as well on one-on-one whenever we have a chance to do the field visits.
Thank you both. So the next question is from Susan Hegarty, who says, really interesting talk, thanks. How do you maintain the long-term sustainability of this project? And do you have any suggestions for building a long-term plan for communities?
Yeah, Susan, thank you. I mean, I think that's a really, that's a question that always worries us. We are very fortunate that the moment that we've got like additional funding, we started with the Dunedin project. We were then successful in another proposal by the Water Research Commission, and we've just been successful in another proposal to the Water Research Commission extending the project. So it started 3 years ago and it's been extended through funding again and again, and hopefully after this it'll be extended again. But we do need to set in place measures that make the project sustainable, and that once we retreat and we're not successful or we don't keep on getting funding, there is the motivation of the citizens to continue. I must just say that in the beginning, the citizens, the eagerness that we speak about, was very real and very tangible. And they didn't ask for anything, like money or anything in exchange. All they wanted was a certificate of, to say that they were citizen scientists. And we're now getting T-shirts printed, which was also a request. And Innocent's been taking hampers of food, which was not asked for and has been kind of received, obviously, with huge appreciation. And so there isn't remuneration. Citizens have been collecting the data without expectation of any kind of monetary remuneration. And as I say, the hampers are quite new, so they weren't expecting them. We're hoping through the creation of these champions, and Innocent has now identified 2 champions, that the champions will take over and keep things going.
Thank you, Jackie. And we have a final question from Jermaine Owen via Bella, which is, how long does it take to train the citizen scientists?
Hi, Jermaine. Nice to see you here. Jermaine, as you know from the work that that you've done as well, it takes a long time. They often, like in the first part of the project, there weren't sufficient funds for the social component of the project. It takes a long time. There's always what I hoped I brought across in the presentation, this element of surprise, this element of not really knowing where you're going to. And I think that's really important, because what it's saying is that it's an ongoing learning process. You can't say we've arrived. You have new questions that come up, you have new needs, you have kind of next phase, like we've spoken about in this one, the first generation of volunteers have been trained. So in a way, I suppose you can say it took us maybe about a year to train the first generation of volunteers. Now we're into the second generation of volunteers, and probably that will take, another year before they're up and running and can read the data. And so possibly, if you have to put a time to it, but I don't like putting a time to it, we could say a year. I mean, of course, you can say, look, the actual training, how to use the dip meter, you can do it in a workshop. You can do it, in sort of a 1-day, 2-day workshop. But that's not what it's about, because knowing the technical, how to put a dip meter into the ground and how to read it is not enough. It's hard to keep on doing it. It's hard to be part of a project. It's this ongoing, I like Carolina's idea of agonistic learning. It's this ongoing kind of learning process. It's not a one-off. Yeah.
Thank you very much, Jackie. And thank you also, Innocent, for your contributions as well. There's no more questions, so I'll just take this opportunity to thank everyone for attending, and to thank you once again, Jackie and Innocent, for a very, very interesting presentation. Thank you very much.
Thank you. Thanks, Tim. Thanks for organizing it all, and thanks for everyone for being there. And thanks, Innocent. Okay. Bye.
Thank you. Bye.
Thank you.